Welcome back, focused learners, to another explainer. We are diving straight into a truly monumental topic today. For those of you gearing up for advanced examinations, especially if you're tackling climate and agriculture relationships for something like UPSC Paper 3, this one is absolutely crucial. We're looking at the Indian monsoon. But as we're going to unpack today, the monsoon isn't just a weather event. It is a massive, complex atmospheric engine that literally drives India's agriculture, dictates its microeconomic health, and is deeply woven into the very fabric of its culture. So we're going to break down the mechanics, the global impacts, and the profound dependencies created by this one defining season. Let's get into it. Here's our roadmap. We are taking a strict systems analysis approach today. First, the mechanics of the monsoon. Second, the global drivers of Indian rainfall. Third, predicting the unpredictable. Fourth, India's agricultural lifeline. And finally, the monsoon economy connection. Okay, starting with part one, the mechanics of the monsoon, or the atmospheric engine. Let's look at how this whole thing actually starts. At its absolute core, the monsoon is defined by a seasonal reversal of winds, and it all comes down to differential heating. During the summer, the massive Indian landmass heats up way faster than the surrounding Indian Ocean. So all that hot air over the land rises, and it creates this huge low-pressure zone. Well, nature abhors a vacuum, right? So this massive low-pressure void forcefully sucks in cooler, heavy, moisture-laden air from the high-pressure regions out over the sea. When those ocean winds finally hit the landmass, they drop all that moisture as widespread rain. It's essentially a gigantic thermal engine. Now, India actually experiences two distinct monsoon phases. The main event is the southwest monsoon, which runs from June to September. This is the primary engine. It dumps over 70% of the country's annual rainfall and is the absolute lifeline for summer kharif crops. But as winter approaches and the land starts to cool down, the entire system reverses. This gives us the northeast monsoon from October to December. And while it's definitely less intense overall, these retreating winds are incredibly crucial for southern regions like Tamil Nadu, and they're vital for winter rabi crops. To actually measure how well this massive system is performing, meteorologists use something called the long period average, or LPA. If you are studying climate dynamics, lock this keyword in. The LPA represents the average June to September rainfall, and it's calculated over a rolling 50-year period. Right now, that magic baseline number is 880 millimeters. So whenever you hear a forecast predicting a normal or deficient monsoon year, it's always being measured against that 880 millimeter benchmark. Moving on to part two, global drivers of Indian rainfall. Because while the monsoon physically happens over the Indian subcontinent, its strings are actually pulled by highly volatile forces far beyond it. The first major driver is the Intertropical Convergence Zone, or the ITZ. You can think of the ITZ as this intensely dynamic, hot belt near the equator where global trade winds literally crash into each other. During the Indian summer, this heat zone positions itself right over the landmass, which helps pull those moisture-heavy winds inland. But by September, as northern temperatures drop, this whole zone shifts southward toward the equator. That effectively drags the monsoon winds away and kicks off that retreat phase we talked about. But the most famous global drivers sit thousands of miles away in the Pacific Ocean. We've all heard of El Niño. When the eastern Pacific gets unusually warm during an El Niño event, it severely disrupts the flow of moist winds to India. Historically, this triggers dry spells, severe heat waves, and terrible agricultural droughts. On the flip side, we have La Niña. This is the cooling of the Pacific, and it often turbocharges those moisture-bearing winds. That boosts the southwest monsoon, which sounds great for farming, but in extreme cases, it brings completely devastating floods. And just to make things even more complicated, we have two other critical variables. The Madden-Julian Oscillation, or MJO, isn't a stationary thing like El Niño. It's actually a moving band of wind and pressure that circles the equator. If its timing is favorable, it can significantly enhance Indian rainfall. Then there's the Indian Ocean Dipole, the IOD. This is basically a temperature difference between the eastern and western sides of the Indian Ocean. A positive IOD generally means more rain for India, while a negative one can suppress it. Ultimately, the monsoon success is just this delicate, high-stakes interplay of all these overlapping global forces. Which brings us to part three, predicting the unpredictable. Because these global factors are so volatile and so wildly interconnected, predicting the monsoon has literally been a grueling 150-year scientific struggle. The evolution of this forecasting is quite a journey. It started way back in 1877 following a devastating famine, when meteorologist Henry Francis Blandford first tried to correlate Himalayan snow cover to upcoming rainfall. By 1904, Sir Gilbert Walker realized the monsoon was actually tied to global pressure variations. For decades after that, statistical models just struggled to get it right. But look at the modern leap. In 2012, India launched the dynamical MMCFS model, bringing together ocean, land, and atmosphere data. And then, finally, in 2021, they adopted the Multi-Model Ensemble, or MME. This takes predictions from multiple global climate centers to create a single, highly robust forecast. The India Meteorological Department then has to translate these highly complex models into actionable advice for the public. They do this using a straightforward color-coded alert system. Green means you're totally fine, no warning. Yellow means watch and stay updated. Orange means alert, be prepared for heavy rain. And red means warning, take action. Now, an important note here. A red alert isn't just a generic bad weather warning. It's a very specific quantitative alert for extremely heavy rainfall exceeding 204.5 millimeters, meaning authorities need to prepare for immediate impacts. All right, moving into part 4, India's agricultural lifeline. We're dropping from the global atmosphere right down into the soil to examine the core climate and agriculture connection. India's agricultural vulnerability is pretty stark. Even after decades of infrastructure development, only 55% of India's net zone area has actual irrigation coverage. That leaves a massive 45% of farmland completely rain-fed. Let that sink in. For nearly half of all cultivated land in India, the monsoon is the only irrigation system they have. If the rains fail, the crop fails. It really is that simple and, honestly, that terrifying. To truly grasp the human scale of that vulnerability, just consider this number. 64%, nearly 2/3 of the entire Indian population, depends on agriculture for their livelihood. So the performance of these seasonal winds directly dictates the food security and the basic financial survival of hundreds of millions of people. And this puts the Indian farmer in a brutal no-win dilemma. On one extreme, you have excess rain from things like La Niña, which floods fields, completely washes away planted seeds, and displaces whole families. On the other extreme, deficient rain, perhaps from El Niño, leads to severe drought, parched crops, and catastrophic loss of income. Both extremes of this delicate climate system carry incredibly heavy economic and human costs. However, when the system works perfectly, it actually gives India an incredible advantage: massive crop diversity. The heavy southwest monsoon creates exactly the right flooded conditions for kharif crops like rice and cotton. Then, completely separate from the monsoon, winter weather systems, known as western disturbances, bring just enough gentle rain to North India to support entirely different rabi crops like wheat and mustard. This distinct seasonal zoning means India can cultivate a wider variety of produce than almost any other nation on Earth. So, monsoon farming is essentially a double-edged sword. Yes, the heavy, concentrated bursts of monsoon rain cause severe soil erosion, quietly washing away fertile topsoil and threatening long-term productivity. But on the flip side, unlike temperate countries where freezing winters just halt agriculture completely, India's monsoon-shaped climate stays warm enough to allow for near-continuous, year-round farming. Let's move to our final section, the monsoon economy connection. Because agriculture is so deeply tied to this climate system, those outcomes inevitably ripple outward to dictate the macroeconomic health of the whole country. Think about this quote from Guy Fleetwood Wilson, a senior British official back in 1909. He said, "The Indian budget is a gamble on the monsoon." Well, more than a century later, the House is still playing those exact same odds. The monsoon is not just a meteorological event. It is quite literally the most critical economic event of the entire year in India. This gamble plays out through a massive economic multiplier effect. A good monsoon directly yields higher farm output. That agricultural surplus translates into better income for that 64% of the population we talked about. When rural India has money in its pockets, they spend it. They buy tractors, consumer goods, clothes. This massive surge in rural demand stimulates manufacturing, it lifts local businesses, and it ultimately drives the GDP growth of the entire country. A strong monsoon literally lifts the national economy. But the monsoon's reach goes way beyond GDP and agriculture. It permeates the very soul of the subcontinent. It dictates food habits, architecture, and art. Take this 16th century Harivamsa folio, depicting Lord Krishna lifting Mount Govardhan to shelter villagers from torrential rains.
For thousands of years, the monsoon has been celebrated as a bringer of life and feared as a force of divine destruction. It really is a defining motif of Indian culture.
Which brings us to a critical closing thought. The monsoon is this ancient, perfectly balanced system that an entire civilization relies on. But global climate patterns are shifting. Oceans are warming, El Niño events are becoming more erratic, and extreme weather is definitely on the rise. So I leave you with this question to ponder. As this massive atmospheric engine becomes less predictable, how will India adapt its deeply entrenched agricultural and economic systems to survive? Thank you for joining me on this deep dive, Focused Learners. Keep questioning, keep learning, and I'll catch you in the next explainer.